Good morning, everyone. Today we are going to study energy levels of sodium atom. So, what is the energy levels? I am explaining here the energy levels. There are two major lines in this energy level diagram. This is the vertical line. In this vertical line, we are taking energy in electron volt. Okay, this is the horizontal line, and this in this horizontal line we will take the term values. Okay, so suppose this is the two energy levels. Suppose this is two energy levels. This is E1, this is E2. Okay, so we know that this energy goes on increasing like this way. So, and these all energy levels are degenerate levels. So that means each energy level have a same energy. So this is two energy levels, and difference between two energy levels gives us a frequency of the radiation. Okay, gives us a frequency of radiation in wave numbers. Okay, frequency of radiation in wave numbers, that is centimeter inverse. Unit of this frequency is centimeter. Frequency of radiation in the form of wave number. So this is the wave numbers. What is wave number? This is the reciprocal of wavelength. So wavelength is in centimeter. So this is the wave number is centimeter inverse. So this frequency we will get in the form of wave number, that is centimeter inverse. So here 0 energy like this way, -3, -2, -1, and this is the 0. Okay, so this is here 0 of the energy is drawn at the top of the figure and other states below. Okay, 0 energy level at the top and others are below. So this is the speciality of this energy level diagram. So we are consider here the energy levels of the sodium atom. Okay, so we will see first the atomic number of sodium. What is the atomic number of sodium? 11, and having electronic configuration 1s2, 2s2, 2p6, 3s1. That means here this is the K shell and this is L shell. Okay, this is K, this is L. Here K and L are completely filled shells. Okay, completely filled, and the remaining this level, last level 3s, is partially filled. So electron in this level plays a part in a optical spectra. Okay, so electron in this level plays an important role in a optical spectra. Okay, how many electron in this level? Only one electron. So this electron plays an important role in the optical spectrum of the sodium. So this therefore the 3s electron when excited like this, suppose this is the two energy levels and this electron in this level 3s. Okay, suppose 3s level. Okay, when this 3s electron excited means what? This electron may absorb the energy and goes to the excited state. So it jumps or excited to the higher energy level, that is 3p, 4s, 3d, 4p, 5s, 4d, etc. Okay, so this 3s electron can jump or can excite into the higher energy level. This is the higher energy levels. So this is a low energy level as compared to this level. So this electron in this 3s level can jump or excited to this higher energy level. कुठल्या कुठल्या एनर्जीला जाऊ शकतो तो? तर 3p, 4s, 3d, 4p, 5s, 4d etc. ओके, डिपेंडिंग अपॉन द अमाऊंट ऑफ एक्सायटेशन एनर्जी. त्याच्याकडे किती स्वतःकडे एनर्जी आहे, किती एनर्जीनं तो एक्साईट होतो आहे. ओके, जेवढी त्याने ॲब्झॉर्ब केलेली एनर्जी आहे तेवढ्या किती जास्त प्रमाणात एनर्जी त्याच्याकडे आहे तेवढ्या अमाऊंट ऑफ एनर्जीनं तो कुठल्या लेवलला जाणार आहे ते ठरतं. ओके, सो इट डिसाइड्स, it is dependent on the how much energy have the electrons have, so that much energy is required to jump this electron from lower orbit to the higher energy orbit. So it is depending upon the amount of excitation energy. So when this electron return to the ground state, okay, so here in this case, here is a ground state and here is the excited state of the electron. So after excitation this electron is in this state. So after the excitation this electron remain in this state up to 10 raised to minus 8 seconds. So after that it will return the ground state, but while returning this electron emits energy in the form of spectral lines, in the form of various wavelengths, in the form of frequency. Okay, so while returning to the ground state this electron emits energy in the form of frequency or in the form of spectral lines. Okay, and ते कशावरती डिपेंडंट आहे? तर इट इज डिपेंडंट ऑन द व्हॅल्यू ऑफ L. ओके, here this is the ground state E1, this is the excited state E2. Suppose here electron, when excitation this electron goes here and after returning this energy emitted the frequency in the form of spectral lines. Okay, so these spectral lines, there is not only one spectral line, there is so many spectral lines here. So this is the series of these spectral lines and this series depending on the कशावरती डिपेंडंट असते ती सिरीज, कुठल्या कुठल्या व्हॅल्यूवरती डिपेंडंट आहे? द व्हॅल्यू ऑफ ऑर्बिटल क्वांटम नंबर L. ओके, सो दिस व्हॅल्यूज gives us 0. We know that this value having this orbital quantum number having value 0, 1, 2, 3 up to n minus 1. Okay, so this 0 gives us a s orbit, p orbit, d orbit, f orbit, like this way. Okay, so this is the picture behind the how the electron excites to the excited state and return back with giving us a optical spectrum of the sodium atom. So since is only one unpaired electron here, okay, in the sodium atom, in last orbit there is only one electron having up spin. Okay, having up spin like this way. Okay, 3s1 having up spin. So spin magnetic quantum number for this electron is only plus half. Okay, and the multiplicity 2s plus 1. Okay, 2 into half plus 1 gets 2 and multiplicity of this electron is 2. So this is a important point. The normal ground state, आता बघा ग्राउंड स्टेट कुठली आहे त्याची? आता ग्राउंड स्टेट, कारण हाच इलेक्ट्रॉन खूप इम्पॉर्टंट आहे. कुठला? हा 3s इलेक्ट्रॉन. ओके, सो त्याची ग्राउंड स्टेट कुठली आपण कन्सिडर करणार होता? 3s. दिस इज द ग्राउंड स्टेट फॉर दिस इलेक्ट्रॉन. दिस इज द ग्राउंड स्टेट and this electron may excites to the higher energy level. Which higher energy level? 3p, 4s, 3d, 4p. Okay, so ground state of this electron is 3 2s. Okay, what is 2 is a multiplicity and what is s is a s orbit. Okay, so electron is in this s orbit. Okay, having multiplicity 2. So the normal ground state of this 3 2s of the sodium arises from the electron configuration 1s2, 2s2, 2p6, 3s1. Okay. Also stationary states are designated as, this is the electron state. In this state electron are here. So another states are designated as 32p, 32d, etc. So electron may excite in this energy levels. So this excitation is dependent on the value of L, that is orbital quantum number. So dependence of L of energy is very important here. So the L dependence of energy is very important here, to the extent that 4s level lies lower than 3d orbit of the same orbit. Similarly, 5s lies lower than 4d and 4f levels. So here it is important, in this value is very important. Depending on this value, this electron can choose in which electron, in which energy level they can excite. So here 4s level lies lower than 3d. Okay, here like this. म्हणजे काय, ही एनर्जी लेवल आहे, ऑप्टिकल स्पेक्ट्रा आहे, एनर्जी लेवल डायग्राम आहे. तर काय सांगतोय, डिपेंडिंग ऑन द व्हॅल्यू ऑफ एल, दॅट इज दिस इज एस लेवल, पी लेवल, डी लेवल, एफ लेवल. ओके, मग ही कशावरती डिपेंडंट आहे, व्हॅल्यू ऑफ एल. आपल्याला माहिती आहे एस, एल इथं 0 असेल, इथं एल 1 असेल, इथं एल 2 असेल, इथं एल 3 असेल. ओके, सो मग आता आपण इथं बघतोय की काय, कुठल्या ऑर्बिटच्या खाली, 4s लेवल कशाच्या खाली आहे, कशाच्या खाली आहे, इथे लाईज लोअर दॅन 3d, इट लाईज लोअर दॅन 3d ऑफ द सेम ऑर्बिट, Similarly 5s lies, where is 5s? Similarly 5s lies between lower than 4d, याच्यापेक्षा ही खाली एनर्जी लेवल आहे, and 4f levels. Okay, so this is all about the basic picture of the energy levels. So now we will move further and we will learn here selection rules. Which point? Selection rules. So what is selection rules? Definition of the selection rule. We have seen that the transitions can take place between S and P, P and D, D and F. Okay, here this is the energy level diagram. We have seen here, this is the transitions. It is possible the transition between electrons from the levels 3p to 3s. So it is possible here the transition between S and P. Okay, S and P. It is possible transition. P and D. And D and F. But under normal conditions. No transition, but under normal conditions, no transition can take place between S and D. Okay, S and F, and P and F. So only possible transitions in between S to P, okay, S to P, P to D, okay, D to F, but not in S to D and F. Okay, D to F. Sorry, not in S to F and P to F. These are the not possible transitions here. So this is the possible transitions of the electrons. This is the energy level diagram. So we know that in this energy level diagram, vertical line shows the energy and this axis shows the term value. So here we are taking n is equal to 1, n is equal to 2, n is equal to 3 and n is equal to 4, like this. Okay, and this is the energy level as comparison with the hydrogen atom. So this is the s, p orbit, d orbit and f orbit. Okay, so in below 0 there are some of energy levels. At the top there is a 0 and below this there are number of energy levels. Okay, so energy going on increasing. Okay, as we seen here, energy going on increasing. So this is the various energy levels: 3s, 3p, 3d, 4f. Okay, like this way. So there is only possible transition between s to p. Okay, s to p, s to p. Here electron is in 3s energy level, so it may excite to the higher energy level. Which higher energy level? It may excite to the 3p. After 3p they will excite to the 4s. Okay, these are the energy levels. So it is only possible energy levels. Electron may excite to the 3p, 4p, 5p, 6p. Okay, electron may excite to the 4s to the 3p, 5s to the 3p, 6s to the 3p, 7s to the 3p. Okay, so after that it will goes to the higher energy level. It is possible transition in between 3p to the 3d. Okay, p to d orbit. So this is the transition 3 to 3, 4d to 3p, 5d to 3p, 6d to 3p. So here also electron can excite from this energy level to the this energy level. Which energy level? D to F. So it is possible transition in between this energy level, because here delta L is equal to plus minus 1. Okay, only selection rule of this energy levels is delta S is equal to plus minus 1. So this is the plus minus 1, means L is equal to 0 here, L is equal to 0 here. So it can goes from plus minus up to plus minus 1. So here 3p to 3s, this is the plus minus 1 energy level. Okay, L is plus minus 1. So it can go here or it can go there, plus minus 1. So this is the possible transition in between 3s to 3p. Okay, s to p, p to d, d to f, but not possible from s to d or s to or p to f. So this is the all about energy levels. So this is the n is equal to 1, n is equal to 2, n is equal to 3. We know that suppose like this, here this is k, l, m, n. Okay, in this k there is only s, sp, s, here 3, spd, here 4 orbits, spdf. Okay, so here n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4. So like this way. Here n is equal to 1, only one s subshell is here. When n is equal to 2, there are 2 subshell, that is 3p, 4s. Okay, when n is equal to 3, there are how much subshells? This spd. Okay, when n 4, there is 4 subshell, that is spdf. So this is all about the energy levels. Now we will move further and we will see here selection rules. So definition of selection rules. General rules concerning the transitions which may occur between the states of a quantum mechanical physical system are known as selection rules. Okay, so but we have seen that transition can take place between S and P, P and D, D and F, but under normal conditions, no transition can take place in between S and D, S and F, or P and F states. So it is because of certain restrictions in transitions called selection rules. Okay, so this is the selection rules, definition of the selection rules, and here these selection rules depend on the transition of electron from higher energy to the lower energy. So this is the selection rule for L, this is the selection rule for J, this is the selection rule for S, selection rule for small n. So what is L? Orbital quantum number. It gets delta L is equal to plus minus 1, that is transition take place only between levels whose L quantum number differs by 1. That is only one these lines are observed for which the value of L changes by plus minus 1. So प्लस मायनस 1 एकतर एस पासून पीला तरी जाईल किंवा पी पासून एसला तरी येईल, म्हणजे एकचा डिफरन्स असायला पाहिजे, एनर्जी लेवल त्याच्यामध्ये एकचा डिफरन्स असायला पाहिजे, म्हणजे तो खाली तरी जाईल किंवा वरती जाईल. प्लस मायनस आहे म्हणजे पी पासून एसला जाईल किंवा पी पासून डीला जाईल असं होईल. आपण बघितलंच इथं याच्यामध्ये बरोबर. इलेक्ट्रॉन एस पासून पीला जातो किंवा पी पासून डीला जातो. प्लस मायनस 1 लेवलचं सिलेक्शन रूल आहे, म्हणजे तेवढं लिमिटेशन आहे तिथं. सिलेक्शन रूल फॉर एल ऑर्बिटल क्वांटम नंबर किती असायला पाहिजे? प्लस मायनस 1. म्हणजेच काय, एस पी डी इलेक्ट्रॉन कुठं जायला पाहिजे? एस पासून पीला तरी जाईल किंवा पी पासून डीला तरी जाईल. ओके, डायरेक्ट असं जाणार नाही, डायरेक्ट एस पासून एफला जाणार नाही किंवा एस पासून डीला नाही जाणार. कसं जाऊ शकतो? एकतर एस टू पी जाईल, पी टू डी जाईल, ओके, किंवा डी टू पी येईल. Then the selection rule for J, this the total angular momentum is also plus minus 1 or 0. So this angular momentum depends on the value of, we know that J is equal to L plus S. So this is the dependent on L and S. So L, we know that it is plus minus 1 value of this L, and this S becomes plus minus 1 half. So it may plus minus 1 or 0. 0 to 0 excluded means what? There is not available the transition between 0 to 0. There is not allowed. The transition between 0 energy level to the 0 energy level. This is not allowed transition for J. Then the selection rule for S, delta S is equal to 0, which means that states with different S, hence different multiplicity, and do not combine with one another. So याच्यामध्ये काय आहे, डिफरंट स्टेट्स आहेत एसच्या, म्हणजे काही इथं डिफरंट आहेत. मल्टिप्लिसिटी म्हणजे 2s + 1 डिफरंट आहे इथं, मल्टिप्लिसिटी डिफरंट आहे. म्हणजेच काय, इट डू नॉट कंबाईन विथ वन अनादर. ओके, इट डू नॉट कंबाईन विथ वन अनादर. नेक्स्ट, द सिलेक्शन रूल फॉर n. According to Bohr theory, there was no restriction on changes in n, that is it takes positive integral values. This is selection rule for L plus minus 1. So this is important, very important selection rules. So by using this we can draw the spectra of the sodium atom. So this is all about today's lecture. We will see next lecture, sodium atom spectra of sodium atom. So thank you.